Hi, this is Stelios from the Tesseract Academy. In this video, we're going to be talking about a very interesting area of machine learning. We're going to talk about anomaly detection. So anomaly detection, or outlier detection, as it is sometimes called, is the search for items or events which do not conform to an expected pattern. So you can see an example of this in that image. Now you're going to ask me, what is the expected pattern? Well, this is domain specific, and we'll see some examples later on. Anomaly detection is applicable in many domains. So we can use it to detect intruders in networks, fraud, faults. We can use it in the medical domain to detect whether someone's heart rate or other physiological metrics are not acting as they should. And it's also used in machine learning pipelines sometimes, and in statistics as well, in order to remove data points which might affect the result in a negative way, and we do not consider them representative of our sample. There are three different kinds of anomalies. We have point anomalies, contextual anomalies, and collective anomalies. So let's see each one of those in turn. Point anomaly is a data point which is considered as anomalous with respect to the rest of the data. So it's the simplest kind of anomaly. For example, credit card fraud. Let's say that someone steals a credit card and then they just start spending this money on whatever they can find. So you have a user's transactions from the past, and you know that this user, most of the time they're using the credit card to go down to the grocery store, to their local pub. So if suddenly the system observes that someone is using this money to play in a casino, and then they buy a car, then they book some trips, things like that. So we have these individual points, and each one of those points really do not seem like something that our real user would do. This is a visual example of point anomalies. So you can have, for example, a center and some outliers at the periphery, or you can have groups of data, as you can see on the right-hand side, and you can have some points which seem to sit in isolation. Contextual anomalies are anomalies that are considered as such by taking the context into account. So for example, if we have data that includes the notion of space, then the latitude and the longitude are contextual attributes. In time series, the contextual attribute is time. So for example, let's say that you want to detect intruders in a network, or you want to detect spikes in social media activity. So what might make these bursts of activity special is what's happening around them. So maybe in a network you see not much traffic and suddenly you see a spike in traffic. It's the same with social media. So this spike wouldn't be anomalous if the traffic was very high anyway. However, if you have low traffic and the sudden spike out of nowhere, this is considered an anomaly. This is an example of anomaly detection in social media. So you can see here a time series, which is the search volume for the term puppy. And you can see that you have various anomalies on this chart. So for most of the year, there's not much happening. Traffic is pretty normal. And then around the beginning of a new year, you can see that you have a spike, and then we return to normal activity. So in this context, the spike is an anomaly because we didn't have activity, that strong activity, for a long time. However, the point after the spike is also an anomaly because suddenly we have a very big drop from the previous point. This example here is a definition of a contextual anomaly. The final kind of anomalies is collective anomalies. This refers to instances which, in isolation, they might not be unusual, but when you take all of this together, then suddenly you have a collective anomaly. Their behavior as a whole is not normal. So there can be two kinds of variations of this theme. One is that events that take place in unexpected order. So let's say, for example, that you have some data points which you expect to be ordered. So you might have a heart rate or brain activity. For example, when someone sleeps, you expect that the sleep patterns, the sleep stages, they follow a certain progression from light to deep sleep to REM and then the opposite. So if this order is not followed, then you can talk about a collective anomaly. In some cases, we have individual anomaly. However, if this person made many isolated purchases which individually didn't look weird, but overall they amounted to, I don't know, tens of thousands of dollars or pounds or whatever, then this would be considered a collective anomaly. This person, within a day, for example, they would never spend as much money. So there are many techniques for us to detect anomalies. So we have distance-based techniques, we'll have some techniques borrowed from supervised learning, such as one-class support vector machines, neural networks. Anomaly detection is a special field in its own right. A technique that I just believe is worth a special mention and I particularly like comes from Twitter. So Twitter released a package for anomaly detection in time series and social media data. I just like to mention this because I've worked a lot with social media data and I've also used this package. And this package is basically an adaptation of a statistical test. And their test, the test that Twitter developed, is called Seasonal Hybrid ESD, which stands for Extreme Studentized Deviate Test. I won't be going into many details. However, the main idea behind this test is that it detects whether there's a number of outliers are in the data set or not. Yeah, it's an old idea which has been adapted to also include seasonality. It was first formulated by Rosner in 1983. And seasonality is obviously very important in social media data, and we already saw an example of that. Yeah, we saw the example previously where the term puppy seems to be more active towards the beginning of the year. So there are various parameters that you can choose in order to play around with this algorithm, such as the maximum number of anomalies you expect, the direction of the anomalies, do you care only about the positive direction or the negative or both, the significance level obviously, and the period of observation. Coming back to this slide, for example, you can see that if you don't tune your parameters right, you might end up with many anomalies being indicated here, whereas you might want something more like this. Yeah, you might want the algorithm to indicate the existence of a single anomaly. So this was a summary of anomaly detection and a few applications. And to sum up, the most prominent applications of anomaly detection are in cybersecurity, in fraud detection, in social media monitoring, and in medical monitoring. So it's a very useful field of machine learning, and there are many interesting applications of anomaly detection, and we have new algorithms constantly coming out, better and better models. If your particular use case is one of those areas, if you might believe that you might be affected by fraud, you or your users, or if you are into social media monitoring or into some of the other examples we mentioned, it's definitely an area that it's worth keeping your eyes on. So this was Stelios from the Tesseract Academy. I hope you enjoyed this video about anomaly detection, and I hope to see you in some other of our videos. Thank you and bye.